Two students are on a balcony 19.6 meters above the street. One student throws a ball vertically downward at 14.7 meters per second. At the same instant, the other student throws a ball vertically upward at the same speed. The second ball just misses the balcony on the way down. So the diagram here, we have all the values, both initial velocity, the constant acceleration, gravitational acceleration, and the distance from the top to the bottom. And I set the value here as the top at 0, and then we made it going up positive, going down negative. What is the difference in the two balls' time in the air? So I use this kinematics equation since we do have the displacement, which is negative 19.6 meters, both initial velocities and acceleration. So we're looking for time here, and we just have to find the difference between those two times for the two balls. So the first one, I ignored the units for now, and I brought them back at the end, as you can see here, since I have a certain purpose, since it would look easier to solve out and everything. So then once you plug in the numbers, it would be negative 19.6 meters equals negative 14.7 meters per second times t seconds plus 1/2 times negative 9.8 meters over second squared times t squared seconds. And if you distribute this and you move it to the left, you see it's a quadratic equation. So, and it's not that, it doesn't look very nice, so you would probably have to use the quadratic formula, and then it turns out to be a really nice value. So you just plug in the numbers and then you distribute it, and then once you get to here, since time can't be negative, we want to make this positive. So then I cross out the sign that would make it negative, so we could get the positive time value. So once you cross it out and calculate that, it becomes 1 second. And then the second ball, basically the same process. Negative 19.6 meters equals 14.7 meters over a second times t second plus 1/2 times negative 9.8 meters over second squared times t second squared. Yeah. And then move it to the left, becomes a quadratic equation, do the same thing, and remember to cross out the sign to get a positive time value, which becomes 4 seconds. And since we have to find the time difference, we'd want to subtract this to this, so 4 seconds minus 1 second, and it would be 3 seconds. What is the velocity of each ball as it strikes the ground? So I use this kinematics equation since we found out the time from the previous part of the question. We have the acceleration and initial velocities. So the first ball here, so final velocity equals negative 14.7 meters per second plus negative 9.8 meters per second squared times 1 second. So just plugging the values and calculating, and it turns out to be negative 24.5 meters per second. The second ball, final velocity equals 14.7 meters per second plus negative 9.8 meters per second squared times 4 seconds. And once you calculate that, it turns out to be the same velocity, so negative 24.5 meters per second. How far apart are the balls 0.8 seconds after they are thrown? I went back to using this kinematics equation since we can't really do anything about final velocity, and since we're looking for displacement, since how far apart, and we have the acceleration, time, and initial velocities. So the first ball here, change in x equals negative 14.7 meters per second times 0.8 second plus 1/2 times negative 9.8 meters per second squared times 0.8 second quantity squared. And that turns out to be negative 14.9 meters, which makes sense conceptually, since if I put the top of the balcony at 0, this would be a negative value since the first ball is thrown vertically downward, so it has to be a negative value. And then the second ball, change in x equals 14.7 meters per second times 0.8 seconds plus 1 over half times negative 9.8 meters per second squared times 0.8 second quantities squared. And turns out to be 8.62 meters, which we could possibly think that's positive since it's thrown upward. And we would want to find the difference since how far apart the balls were after 0.8 seconds. So, and we would want to get a positive value. So I put 8.62 meters and then minus negative 14.9 meters, which makes this into a positive number, which becomes 23.52 meters.